So we are rolling.
All right, I'll kick it off. All right, welcome to the Munro Live podcast. Today we have Tom Kelly, the Executive Director and CEO of Automation Alley. So Tom, thanks for joining us. Can you tell us a little bit about yourself and your role with your organization?
Hey, thanks for having me. This is great to be here. I'm a big fan of Sandy's work and what Munro does, and I know Sandy's a big supporter of us at Automation Alley. So your audience probably doesn't know who Automation Alley is. We were started back in 1999. I promise not to give you 23 years of history, but we were started by Brooks Patterson, which was the county executive for Oakland County. And back in 99, you may recall that it was Michigan was sort of on hard times, and people, were saying that we were the Rust Belt. We were lumped in with Michigan and Ohio and Indiana and Buffalo and out to Wisconsin. And what happened was Brooks did this study, and the study showed that outside of Silicon Valley and the Boston corridor, we had more software engineers in Southeast Michigan than anywhere else. And they were all classified as auto workers. And so he went about forming this organization called Automation Alley to really change the perception that this is a very high-tech area. And The Economist had coined this term Automation Alley to talk about the automation that was occurring, sort of doing that. The Economist is good at doing this under the radar kind of stuff. And they coined this term Automation Alley. They said, you got to pay attention to what's happening in Michigan because of the robotics and things that are happening. So we co-opted that term, and we had 8 counties join us, and it was really to change the perception. Now, if you fast forward to 2016, when I came in as the executive director, we pivoted a little bit. We were an association that was a cheerleading organization to really bring people together to celebrate all the technology and things that we do in Southeast Michigan. I saw in 2016 this shift that was occurring on the global stage, which really was the fourth industrial revolution. It was the digitization of everything. Tesla is a great example of the digitalization of the auto industry and how they've driven that just beyond EV, but into how you actually make the vehicle itself. So Automation Alley, we pivoted and said, we need to be the organization that helps our manufacturing community understand this digitization. And the reason why I felt that was so critical was that Michigan invented the second industrial revolution. The first was steam and the locomotive. The second was Henry Ford and the assembly line. The third was computers and robotics. And this fourth is the digitization of everything. Software is going to eat the world, right? That whole thing. And so because Michigan invented the second industrial revolution, we built systems to maximize wealth around this idea of the assembly line and the idea of this capital-intensive way of producing things. The risk we have in Michigan specifically, and for all manufacturing communities, is that the fourth industrial revolution is about tearing down all of that fake capital that is required, right? The way it used to be, and going with a software methodology that says, I'm going to have a software first methodology, and then I'm going to have a capital light business. I'm going to use 3D printing where I can, because I don't have to have all these machines that bend metal this way and then bend metal back that way and then add a little bolt here and then do something else. It's like I can just print it all in one go. Or I can use sensors to inform what I'm doing and how to get better at it. So we're seeing a fundamental shift in manufacturing that is going to go from capital intensive to capital light, and it's going to shorten the time to market. Mass customization, which when I came out of school as an electrical engineer back in the 80s, we talked about, the world's going to be mass customization. Well, it never happened because the cost of doing things was so expensive that you really had to understand manufacturing, and you were divorced from design. An engineer would design something, a manufacturer would then get it and say, you don't know what you're doing. Let me redesign this so we can actually make it in a factory using all these machines. We're getting back to this pure form where engineers can design things or people can create things, and poof, you can make it out of thin air with zero manufacturing expertise. Let that sink in for a while. I'll repeat that. you can now be a manufacturer with zero manufacturing expertise. And this is the change that we're trying to educate the world on, and most specifically trying to educate Southeast Michigan and all of Michigan, because Michigan is outsized dependent on manufacturing. 20% of our GDP is derived from manufacturing. Most of the United States, it's 10% or less. So you see, we're all kind of all in on manufacturing, but we're all in on manufacturing the way we used to do it. And so we need to help our supply chain. The OEs and the big guys, they're kind of racing as quick as they can. And someone like a Tesla or a Polestar really helped them see religion of what it means to be able to be a new manufacturer. So that's what we focus on. That's Automation Alley in a nutshell.
Yeah, so you mentioned the transition from Industry 3.0 to 4.0. Where are we at on that timeline? Are we partway there? Are there some companies that have made the transition? Can you give me your vision into the future of when will the whole industry be at 4.0?
What a great question. So these revolutions, as they're called, right? The industrial revolutions, they're measured in generations, right? Now, in today's fourth industrial revolution, that timeline is going to be compressed because of our ability to use computers and how smart computers are getting. And so if you think about the fourth industrial revolution, we think of it as artificial intelligence, collaborative robotics, 3D printing, using sensors to be able to get feedback on what's happening in any given process, right? And I could go on and on. Big data, being able to look at the world and make decisions off it and really improve your product. Any one of those technologies that I just mentioned is completely transformative to how you think about making things. When you marry them all together, it's an exponential on an exponential. And so we don't know how fast this is going to transition, but what I do suspect, and the working theory we have at Automation Alley, is this is going to go much, much, much faster than people are anticipating. And let me give you one specific example that is kind of manufacturing related, but not really. Let's take ChatGPT.
Yeah.
Right? So OpenAI and Google and all these other AI platforms, Siri and Alexa, and you can go down the list of all these AI companies. They were all working on these various methods for how you create a system that can actually provide useful answers and not just search results that you then have to do the work around. And we won't get into the technical background of how that all works. But they're all working and they're all moving along. And then all of a sudden there's a breakthrough. And ChatGPT goes from unheard of in the consumer market to 100 million users in 2 months. Unheard of. Took Google 5 years to get 100 million Gmail users. Google, with the best search engine in the world, right? This puts it in perspective of how things kind of go along and they bounce along the bottom in this sort of innovation cesspool, and then something happens and bam, it comes out and changes everything. And it's not just going to be AI. We're seeing it in collaborative robotics. Walmart just announced that 60% of their retail stores will be fully automated by 2025. I don't even understand what that means. I have to do more research, say, well, what did they actually just announce? They said, no, we're not going to lose any people. We're going to be at the same employment, maybe even more, but we're going to try to automate 60% of our stores by 2025. That's the collaborative robotic effect, right? And 3D printing. If you think about how transformative that is, if you're familiar with a company called Relativity Space. So they just blew off a rocket into space. Now, it didn't make their final orbit, but that wasn't the test. The test was it made it through Max Q. Every engineer in the aerospace industry poo-pooed Relativity Space. Said, 3D printed components can't stand up to the stresses of this rocket technology. It's unheard of. And they proved that rocket that goes from 30,000 components to 300, they proved that rocket could go up. It goes from 60 million to build a rocket to 12 million. It goes from 2 years to build a rocket to 60 days. That is going to remake the entire aerospace industry. So if some of our listeners are in the aerospace industry, they need to pay attention to what happened, because it's not about you getting into the 3D printing business. Because if you're a cog in the wheel of this supply chain, what you do doesn't matter anymore because the entire business model was just changed. So you need to pay very close attention to not what your competitors are doing, because they're all in Industry 2.0 with you. You need to be paying attention to the technology companies that are saying, I don't respect the pedigree of the 100 years of manufacturing skill that you've brought to the table. In fact, that's your Achilles heel. I'm going to do something so different that you are not even able to keep up because you have no skill set to keep up. And that's the scary thing. So that's what we need to focus on, is having our ecosystem pay attention so that they can keep up with this rapid transformation that is occurring.
So is that pushing people into like contract manufacturing role then?
Well, no. I think it's pushing people into understanding that their value is in their intellectual property. Their value is in their brain power. Their value is not in the manufacturing assets that they have, because those will become less and less relevant. The value will be in, take relativity space as an example. The value is in every rocket they build is different from the rocket they built before, right? They've built 52 rockets. The 52nd one went up into space. Every one was built different because they had the luxury to say, look, I 3D print them. I 3D print it, I learn. The next one I print differently. Typically in capital-intensive manufacturing, you create an entire footprint to do one thing extremely well. And the first one, the first car costs $2 billion, and the next car costs $15,000. And then you have to build 100,000 cars to recoup that $2 billion that you did to retool the entire factory, and you hope you have a 4 or 5 year run. That's all going to go away. And we're not going to be in that business anymore of making lots and lots and lots of the same thing. We're going to be in an iterative cycle. And that's where that IP comes in. I need the brain power to say, how do I continuously learn, and how do I continuously reapply that learning to make it better? In fact, Sandy, I was listening to one of his podcasts, and he said, my God, we tear down a Tesla in April. And we gave them ideas of how they could improve. And son of a gun, June, when we tore down that car, that improvement was in there. He said, I don't even know how they did it, because he's thinking like the auto industry, which says, once you set that line, God help you if you ever want to change it. You can't. In fact, everybody tames the lions to keep the line going. Lions and lions. So make sure we know the difference. But do you see how the way Tesla's going about it, it's completely different.
Yeah, and when we tore down that Model Y in 2020 and another Model Y in 2022, we've carefully analyzed all the differences, particularly in the gigacastings, and a lot of different changes here and there. And I think it drives people like Paul crazy, because you're a body and white guy, and I think it's kind of atypical to see that much change in a short period of time, particularly because the Model 3 and the Y are a similar platform. And the Model 3 is nothing like the latest Model Ys. And Sandy and I got invited to the Investor Day down in Texas, and they did a tour for all the institutional investors. Sandy and I were on the tour, and they drove us in by all the castings that were sitting there in racks. We got out and we're immediately looking for even further revisions, and we saw some. Wow. The cutouts and some of the issues that we saw on our gigacasting, the front gigacasting from our 2022 Model Y, they'd already made some revisions to the gates and other things that are little stuff that we would be looking for. And I think it's quite incredible, that iterative change that you were mentioning.
And what's fascinating about this whole conversation is that the technology is not expensive. It's the mindset shift. And that's the Achilles heel of what we're doing in Detroit, and what we're doing with a lot of auto industry and aerospace as well, is we can't get out of our own way. We say, this is the way it's always been, and this is the way it shall always be. And so we need to change that mindset and say, no, we have to live in a world of continuous chaos. And we have to manage that, and we have to be able to get to this iterative cycle where we can make changes continuously, because that's where the world is going. And if you had looked at rockets in the past, you would have said it's impossible to have an iterative cycle where you can do a different rocket every time you make one. Because it wasn't because we couldn't envision it. It's because the systems we had built didn't allow it to happen. But now relativity space has proven that indeed you can do a rocket of one and you can iterate continuously.
So we're seeing the iterations on Tesla using traditional methods like castings, right?
Yeah.
So they haven't taken that second step, the 3D printing yet.
Yeah, well, I think what they're doing is it's a combination of all of the above. So they're using every means available to accelerate this pace of change, right? And I think if they could, one of the things they talk about, I think if they could get to a point where they just cast the entire frame in one go, I mean, they're desperately trying to do that. And everybody said, oh, it'll be impossible. Well, I'm not so sure, right? I'm not so sure that in 10 years, we aren't talking about 3D printing the body in white all in one go, because that makes great sense. Right now, the materials aren't quite there yet. But I would imagine it's not much of a speculation to think that Tesla and perhaps GM and Ford and Toyota and everybody else are working with the BASFs of the world and the Dows of the world and say, hey, I need this kind of powder material that we can build up because I have huge casting plants. I can just as easily have huge 3D printing factories that are just kicking out the body in white and on it goes. And that's really attractive, even though it's outrageously expensive up front. The ability to make continuous change off of that now, 3D cast, maybe I coined a new term, 3D cast model is so powerful that I don't have to have the $1 billion to get to the first vehicle. I now have the ability to create massive iteration.
So I have a question for you about cycle time. So there is a car that's almost 100% 3D printed. I think it's called the Zinger.
The Zinger, yeah. Divergent Technology.
Yeah,
they're a member of Automation Alley.
Yeah, I think the owner is Zinger.
Yeah,
it's
Kevin
really
Zinger.
Yeah, really kind of crazy. But the issue there is it's really expensive and cycle time can really kill you. So we visited a company called Trump, and they have 3D printing machines, but they're limited by size. The most expensive 3D printer, I think they can do like several feet by several feet, and it takes hours or days to finish a part with laser metal sintering. Because we looked into this to helping out some of our manufacturers. And then something like a gigacasting shoots in milliseconds, and Sandy and I stood there in the plant and watched from one coming off to the next, and it was like 47 seconds. So when you're dealing with 300,000, you got to be in the 47-second range, not 24 hours. So yes, you can put 100 machines in a room. So how does that come into play? Throughput and manufacturing methodology intertwined with Industry 4.0.
Yeah, well, it's a great question, and this is the problem that is sort of the $64,000 question. It's what do you pay attention to now that allows you to make profit today, and what do you need to pay attention to that will completely upset the apple cart in the future, right? And I think both are valid. So right now you're saying, hey, this is the best technology to get the best cycle time today. Let me give you some examples of how you can get caught. So if you look in biosciences, it used to be that DNA sequencing used to take years, right? And then it took months, and then it took days, and now it took hours, right? So when you see, and the cost went from, hundreds of thousands of dollars to pennies. And that kind of technological advance that was just so dramatic. And you see what's happening with AI. Today, ChatGPT still costs $100 million to train it. It's only for the very wealthiest tech companies to be able to play in that space. Eventually, it'll cost next to nothing because that's what technology does. It drives things from very, very expensive down to nothing. Auto industry is fantastic at taking very expensive things and driving them down to be cost competitive. The issue that I have is we're not very good at being software first and true technology business. We define technology as that which goes into the Industry 2.0 plant as we understand it. And there's these other ways of doing things that are coming that engineers in the auto industry and aerospace and defense will look at it and say, that's not viable today, therefore I can't focus on it because it doesn't drive my bottom line right now. And that's the risk, because there are people all over the world working on technologies that can supplant this. Right now, the Defense Department is working on building a seamless hull boat. Well, right now it's too expensive. But as we learn and as we get better, if you could kick out the boat in a huge 3D printing machine, again, everybody that's in the boat building industry, if they're not thinking about that and understanding how do I get there, that's to their detriment, because someone with a lot of money will step right in and say, I can take that over. And that someone will typically be a technology company that understands that cost curve reduction, that exponential curve that gets driven down. They will understand that better than traditional companies that are in manufacturing. And that's our whole message, is to really pay attention to how fast the cost curve can get driven down and how fast the business model can change.
So do you see the traditional OEMs becoming less vertically integrated and contracting this stuff out to the
I actually
IP
see
owners?
the opposite. I actually see a future where the OEs become much more vertically integrated, because it's all about quick iteration and rapid change in models and the things that you can do. Think of the Cadillac Celestiq as not the halo car only for the very rich. Think of it as the tip of the iceberg of what's to come with mass customization for everybody, where you'll go in and the whole car maybe have the ability to be customized at a price point that you can afford. That's the future, right? Just like we can do mass customized rockets now, just like we can do mass customized lots of things. We haven't been able to breach that with the auto industry because it's just not there yet. But pay very close attention. Right now, there's 300 plus 3D printed parts on the Celestiq, and it's only going to go up from there, right? And if you see what Divergent is doing, the Zinger, he's just getting started. I think, somebody asked, I can't remember, how far along are we in this transformation? I think we're in the first inning. I think we haven't even begun to see how all of these technologies come together, because they've all been isolated. So we have artificial intelligence and we have collaborative robotics. Those two disciplines did not really interact, hardly at all. And now they're going to interact massively, because the AI is going to be the brains of the robot that makes the work. And once you get to that point, in fact, it was interesting, Elon Musk said that he thinks that his robot technology will be the most valuable thing he ever builds, right? And so think about it. If you take what he's saying is, when you get to a system where a smart robot can do all of the work, mass customization becomes trivial and cheap, right? And that's what he's saying, that the abundance that the world will see will explode because of this ability to drive this kind of future.
Yeah, and we currently don't see a lot of mass customization on Tesla's products. They have very few colors. I think they had 5 to begin with. Now they have a few extra ones that they make in Germany. And you can get a long-range version with a big battery pack. You can get the smaller battery pack with LFP batteries. You can get it all-wheel drive or rear-wheel drive. But it's really, their plant is very Honda-like. I mean, Paul, I don't know if you've ever been in a Honda plant, but they were known for making just like gray Civics for months at a time. But Tesla has really low complexity, compared with a lot of the traditional OEMs where you could order 15 different trim levels and off-road packages and 10 colors. So
I would challenge that. I would say they have very low complexity. They have very low physical complexity. They have very high software complexity.
Oh, yeah.
Right? So think of it differently. So he can change that vehicle, what's possible to change in software. He's invested a ton in that capacity. I would imagine he would say, boy, I would love to be able to physically also have that same level of complexity, but I can't, because he has to make economic decisions that say, I don't do my customer any service if I go bankrupt. I have to limit what I can so that I can drive profit. And by the way, having complex software, that is actually a way to drive profit, because if I put it all in software, the software I can constantly iterate, and my iterations are near free on the scale of things, right? And especially in a manufacturing plant. So he put all of his complexity in software, and that allows him to create these rapid iterations where he's making updates. He hates when they use the term, why did they say I'm doing a recall? I'm doing an overnight software update. It's that easy, right? And nothing has to come back to me to fix physically. And that was the bet he made, and it's paying off. And you're seeing now all the other automotives trying to rush into that space. And it's going to be very difficult because I don't think they're appreciating that mindset, that pace that you need to really understand software and its complexity and how fast you need to move. They still view it as, the tool that's going to be in the car that might add some value here and there. Elon Musk is, the car is the software and the software is the car. And the physical is just a method to make sure it stays on the road and keeps you protected.
Yeah. Yeah. So, Paul, what other questions do you have for Tom?
It seemed from what you said, you admire Tesla and what they're doing. Yeah. Who do you think's number two?
That's a great question. You're going to get me in trouble because I have Ford, Toyota, GM, Stellantis. They're all members of Automation LA. They're all on my board of directors.
Pick your favorite.
It's just like children, right? It's like my children. I think I have to say I like what General Motors is doing. I see General Motors, if you look at all the car companies, they all have sort of a different flavor of how they go to market. And GM's always a platform. They're like, hey, we build the platform and then we go. And I think there might be some real interesting things that they're doing around the platforms that they're building to try and put them in a position to get to that inexpensive scale, right? That's kind of their big play. Is how can we get to innovate to scale? I really like what Stellantis is doing with their new Ram that just came out. I think that's a really fascinating truck because of the range that they're claiming that truck will have. I'm sure engineers would beat me up on all the reasons that's probably not a great thing, yeah. But for the consumer, they may look right past that and say, wow, you mean I can go 600 miles on a charge with this battery? Car weighs 10,000 pounds, but who cares? So it's those kinds of things. And I think Ford is the most interesting. I don't know a lot about what they're trying to do, but they're the ones that separated their businesses, right? They have the Ford Blue and they have the Ford E. And it's very clear in the organization, Blue, you keep making money, but we're going to Ford E. And so they're trying to change the culture. And you see all of these autos are trying to change their culture in different ways, but they all recognize that they have a culture problem. They don't have an engineering problem. They have a cultural problem that they need to move much faster, and they need to get in an iterative cycle that is much more aggressive and much quicker. And they can't get their middle managers to understand that the world is changing around them. Because it's really not the people on the line and it's not the executive suite. They both get what has to change. It's the middle managers that say, my whole career has been built around understanding this simple process and doing it extremely well. And I don't know how to step out of that box. It's just not without massive retraining for me. And this is the difficulty we have because we're living in an Industry 2.0 culture. And we're asking them to now come into this Industry 4.0 culture. And it is a very, very tough road to hoe. And that's why Jim Farley is publicly saying to Cranes and all these publications, hey, we got to change our culture. He's very open about that. And he's getting more, desperate is the wrong word, but he's becoming very aggressive in how he talks about his organization. And he is really trying to change it. And you can almost see the stress in him as he's having these conversations with reporters about how he feels he needs to change the organization very
Do you see any quicker change from the European OEMs or Asia?
I don't know them very well, Paul, so that's hard for I would know as less than you, I think, in terms of looking at what they're doing. They don't swim in our ecosystem so much. I do see that the Europeans and the Asians, a lot of them are settling in the southwest of the United States, and there's a little bit of an advantage in that you can change culture more quickly if there was no culture there to begin with. So you're not changing culture, you're only creating the vision that you want. And I think part of us losing the Ford truck factory to Kentucky and Tennessee, I think, is the concept of the blue ocean, that I can just go down there, and as I start to build people and bring them in, I can create the kind of ecosystem that I need to be successful. So I don't know. I wasn't privy to any of these conversations, but I think that's probably part of Ford's mindset that says, hey, we need to create this new culture quickly.
Yeah. So I want to go back to something you said about General Motors. So you put them at number 2. They talk about,
I don't know.
they talk about their Ultium.
I love them all. Remember, I'm putting this on the record. I love them all.
They talk about their Ultium platform quite a bit. Yeah. And the Lyric, the Hummer, the Blazer, the Equinox, the Silverado EV, they've all been touted quite a bit. But I feel like their deliveries have lagged behind some of the other OEMs. So Ford is delivering quite aggressively the Mach-E and the Lightning. And we've torn them down. We've talked about them. And we've highlighted their inefficiencies from thermal system design. Yeah. And so Ford got to market first, with more of a bang. GM is a little behind, in my opinion. They only delivered 2 Hummers in the first quarter, and they have a full backlog of orders. Yeah. So my question to you is, with the announcement of GM now considering using 4680s before the Ultium platform even hit its stride, is that a concession, or do you think they're having second thoughts or doubts about the pouch style lithium-ion Ultium platform? Because they announced that with great fanfare about 2 years ago, and now they've already announced 4680s as a possible mix. Yeah.
So, full disclosure, we're just having fun talking because I'm an i4O guy. I'm not a battery guy. I'm not a tech guy, but I love the conversation because I too, am intrigued by how this is all playing out. I would encourage you guys to educate me on what do you think happened? Because I think that's fascinating that they're going to the circular battery. Who knows what decisions need to be made, because I think there's, like we talked about, that short-term economic model that says I need to get out to market with a model that allows me to be competitive. And if I'm trying to build this new Ultium platform and it's not quite ready for prime time, it's going to cost me a fortune as I try to scale. I may have to switch over, but it doesn't mean the Ultium platform is dead. It just needs more seasoning, more time to have technology catch up with it, because the platform is actually incredibly interesting the way that they've designed it, but it may be a lunar rover in an age of the smaller vehicle. You're building
and we have a Hummer in the building completely tore down.
Yeah,
that battery report and motor report will be for sale. Yes, shameless plug.
Yeah, fantastic. I need to get one, obviously, because I need to do my homework. Good. That's what we rely on you guys for. It's just fantastic.
Yeah, so we've seen it. It's decent, heavily modularized. Sorry for going back down the technical route. I know your space is Industry 4.0, but
I like the conversation. Yeah, it's really great.
Yeah, very good.
So going back to Industry 4.0, with all these networked robots, computers, there's a security issue there, right?
Oh, totally.
How's that being addressed?
Yeah. So, what's interesting that you just mentioned that. So we just got awarded a grant from the Department of Energy to build a cybersecurity center in partnership with Oakland University. So I guess that's my shameless plug. But we're a nonprofit, so we're going to build this center, and that's part of the issue is. Not just at the plant level, which is a security issue related to that company. But Industry 4.0 is going to require us all to be interconnected. And what that will mean is a cybersecurity issue across all of your supply chain at all moments. And this is going to be one of those wicked problems, as they call them in engineering, that is going to be very difficult to solve, but must be solved nonetheless. So when you see how artificial intelligence and collaborative robotics is going to come together, you better make sure that there's also a deep security issue there. Now, what's nice is all industries are wrestling with this problem all at the same time. And even within automotive, you have two tracks. You have cybersecurity related to making the vehicle, and you have cybersecurity related to the vehicle driving itself. And this actually trumps all. And so I'm hopeful, and I look for what's happening on the autonomous vehicle side to actually help drive how we handle security, because the security on the manufacturing side is quite mundane in relation to the security of making sure the vehicle doesn't drive itself off a cliff because it's been taken over. Not to put that thought in anybody's head, but these are the kinds of things that would be very fearful. So I think it's going to be a dual track approach, and there's going to be great improvement that comes out of what's happening on the autonomous side that will probably be more adopted on the manufacturing side.
So with the 3D printing, I assume there's a huge network of smaller machines making small parts, gluing them together to make a big part, right?
Yeah. So, well, that's another great observation. So, Automation Alley, we have a program called Project Diamond, and it stands for Distributed Independent Agile Manufacturing on Demand. That's the Diamond. And we built this network in partnership with Oakland County, and we stitched together 300 small production-capable printers. These are carbon fiber printers. They can print about the size of a bread box. It's smaller components. But what was interesting, we stitched them all together, and we're working to allow each manufacturer, these are all small manufacturers. Most of them are under $25 million in revenue. Very, very small manufacturers, all within Oakland County, all within driving distance of each other. And we're running a grand experiment that says, can we create a distributed model that takes the capital intensive to capital light? So in other words, if I have IP, if I have a product, a design, if I can get that design securely to the other 299 friends that I have, I can make 300 components at a time with no additional cost to me. I only have the one printer. Now it becomes an economic model of how much do you get and how much do I get? But I certainly don't want to go out and buy another $30,000 printer or perhaps 10. So now I have my $300,000 capital heavy and I got to make a ton of parts. And then I have to keep that monster fed even after I'm done with that part run. So we're building a system, and we've just been awarded phase 2 of that contract in partnership with the federal government in Oakland County. And we'll now be adding another 500 printers to the network. And and these will be all different kinds of printers. And the theory is we see manufacturing going distributed. So we think manufacturing will go software first. We think it'll go additive, and software and additive will lead to the third conclusion that it'll go distributed, right? And it'll go back to the question of, I have the IP. I don't build a manufacturing facility to make that IP. I just push it out onto the network. And I may make it in Japan for the Japanese market. A great example is, why do I ship tubs of resin to China to then extrude millions of Barbie dolls in different shapes and sizes and hair colors to then put on a boat to ship back all over the world to be stocked on shelves? And it's not an ideal product because it's not mass customization. You get a Barbie with blonde hair or brown hair. There's only so many SKUs of Barbies that you can choose from. I see a lot of manufacturing going the way of Build-A-Bear, where, like in the toy industry, why wouldn't the child go to Walmart and actually extrude or build the exact Barbie that they want with the right skin tone, the right hair color, the right shape, the right accessories, everything that comes along with that. And it's manufactured at the point of sale. And you're going to see that really start to take off. You're seeing manufacturing food at the point of sale, where these 3D dessert makers are starting to pop up, and they make these elaborate desserts that say, happy anniversary and things that you couldn't do because they're all customized, right? And now they just start the machine, and at the end it's like, oh, here's your dessert. And the chef has great creativity. So when you see this working on all these fronts, it's really going to be fun to watch. But that's what we're doing. We see manufacturing is going to move to software, then 3D printing, then distributed manufacturing. For the, a big chunk of the market, let's call it 30-40%, there's still going to be stamped metal, right? I mean, don't get me wrong. There's still, and maybe the auto industry will be one of the last ones that sort of crosses over because of the complexity and the volume and the things like that. But there's so much general manufacturing that is if think of it, most stuff that's made fits inside a CNC machine, right? Well, why would I smelt a huge block of aluminum, then cut it into smaller sizes, then ship it all over the world, then put it in a machine to destroy even more of it so I can end up with something that I need when I can just 3D print it right from the start? And it's so much more efficient, so much more efficient. Now, what's missing is the equation is it's so much more efficient for the part, but right now it's too expensive for the machine and the materials. The efficiency is clear. There's no doubt, but the machine and the materials are too expensive. What we're saying to our members, we have 2,000 members now that swim in Automation Alley's ecosystem, is we don't know any more than you when those cost curves cross. But that's your $64,000 question. That's your business model question. Every company in America needs to understand, when will Industry 4.0 cross on a cost perspective what I do as a manufacturer, as a retailer, as a hotelier, right? We've seen this early on. Early Industry 4.0 was done in like the entertainment industry, where Netflix came along and put Blockbuster out of business. Blockbuster saw what was coming. They couldn't change their culture to stay ahead of the business model change. They thought they could just, that the curves will be so slow that we'll ramp down our brick and mortars and our physical discs and we'll slowly ramp up our online. And they completely missed that it moves so fast in the consumer market that you are dust, that the consumer doesn't value waiting. They're just going to move. And that's the risk we have in all industries, is that the consumer ultimately decides how patient they're going to be with you. And if the consumer decides that they're not willing to be patient, they're just going to move. And that's the risk that we have. And we see it coming all over the place. So all we're asking everybody is pay attention to what's happening and then determine when do I change my business model? When does it become critical?
You make a lot of great points there. And even with all this AI tools, ChatGPT, and there's like another 100 tools that'll write presentations for you, proofread your stuff, all sorts of things. So I actually started a small task force inside of Munro with our software team and one of our IT personnel. We're going to investigate all of the tools that are available to see if we can use them, because we don't want to be left behind. We don't want to be Munro and Associates, the company that ignored all these AI tools and gets kind of behind the curve.
The productivity improvement for AI is going to be off the charts. I don't even know. We got to figure out a way to measure it, because, give you an example. I have everybody in my company using ChatGPT and AI to help them in their days. And then we get together for lunch and learns and say, how did you use it? Teach that person how to use it. How did you go? Just a little trivial example. I gave a speech to the Society of Information Managers a couple weeks ago. I came back and they said, hey, we want to go to your Integrate conference, which, by the way, our Integrate conference is May 9th. It's here at Suburban Collection. I encourage everybody to go. It's integrateconference.com. But I came back and I said to ChatGPT, write a thank you letter to the president of the Society of Information Management and extended them a discount for our Integrate conference. And here's where the Integrate conference can be found. And write him a letter that he can send to his membership, encouraging them to attend Integrate and all the things. It was done in 30 seconds. and I had to do maybe a minute of edit. That would have taken me a half hour to write, right? Because you'd wordsmith it, you get, that's not right. No, I got to say it this way. That is going to be the power of ChatGPT, this ability to, you know how it's easier to edit something than to start with a white sheet of paper? It's going to eliminate the white sheet of paper. It's going to say, here's the framework. And say, oh, I don't like that. I hate that. Change that. Fix that. But you are going to become your own editor, and it's going to increase your productivity massively, right? We have other examples where you're seeing these companies. Our COO, Pavan Mazumdar, he asked ChatGPT to write a Python code to do something regarding some data extraction, and it did it. And think about that. It just blows your mind what's going to be possible.
So how do you think that AI and Industry 4.0 is going to affect the job market?
I actually agree with the World Economic Forum. So we're in partnership with the World Economic Forum with our U.S. Center for Advanced Manufacturing. And that center really works to solve the global problems for the very largest corporations. And they did a study a couple of years ago, and it said, I'm paraphrasing because I don't have the numbers in my head, but something like, AI is going to destroy 57 million jobs, globally, and it's going to create 88 million jobs in the next 10 years. So the types of work that will be able to be done, I think the way to think about it is throughout all of history, let's take the United States as an example. Everybody has been worried that robotics are going to take all the jobs and automate. Remember, Automation Alley has fought this battle since our inception. Automation is dirty, it's bad, you don't want it, it's going to steal jobs. We are at 3.5% unemployment, and 2 million jobs are going wanting in manufacturing today because there's nobody to do them. So for all of the technology that we've put to work, we still can't find enough people to do the work. And the reason for that is it's at the age-old issue that says the world wants to get to abundance. And there will always be, it's like an infinity equation. There will always be more to do. And so as you get more and more capabilities with AI, with robotics, with 3D printing, there will be more and more things to be done. And so there will always be jobs to be had, and the jobs get more and more interesting, and more the wages go up with those jobs, right? There's nobody really toiling in fields in America like we used to, because it used to be one guy, one horse, one plow, and what you got done was what that horse and man could do with the plow in one day. Right? And on and on and on. And now there's one farmer in one tractor doing acres upon acres upon acres of farming.
And the tractor drives itself.
And he's just there to make sure the tractor doesn't do anything crazy, right? And we're going to get that in all industries, but it's going to create other opportunities and more important opportunities. The reason why we don't do a good job of educating our kids, which is probably a third rail I just touched. But, this is an issue that everybody talks about, is because the value we place on that is in competition with the value for other jobs. And so people go off and do other jobs. And if you can start creating abundance where you can then pay more for the things that really matter, like elder health care and education and things that really are human-centric, I think we're coming into a golden age. I really do.
Yeah. So, Tom, this has been great. And as an Oakland County resident, I really appreciate you running Automation Alley. And I've heard about Automation Alley for years, and now I have so much more insight into what you do and your organization.
You're always welcome. And we love what Munro is doing. We promo you guys all the time, and we love what you guys are doing. Such great work.
And you said your conference is on May 9th?
May 9th, Integrate Conference. It's on May 9th.
And we can put a link to that in the description of this video. So any of our viewers, if you want to check out that conference, it'll be in the description. And any other contact information? Are you on Twitter, LinkedIn?
Yeah, the easiest place to get information is automationalley.com. You can find me on LinkedIn, and
You're not on Twitter? Got a blue check mark? No?
I might. See, when everybody zigs, you zag, right? If everybody's abandoning the blue check mark, that's the time to get one.
Sandy joined Twitter right after Elon bought it.
Yeah.
And he was put on a 90-day wait list to get a blue check mark because you couldn't get it right away.
Wow.
Because people were using them to spoof and stuff.
Yeah.
He got his blue check mark. He's got like 65,000 followers.
Oh my goodness.
When he posts, he gets 300,000 views, 800,000. So,
well, he's Sandy.
Yeah.
I'm not, if I put a blue check mark, I'd get like eight people
surprised. Yeah, Twitter's where it's at. I like Twitter.
Yeah.
Paul, you're on Twitter?
I'm on Twitter.
Yeah.
I've got like 3 followers. I'm good.
Yeah. Right. Hey, one of them's me, I think.
Awesome.
Thanks for everything, guys.
All right, really appreciate it.
Thank you, Tom. Very interesting.
Thanks.